recording started?
Okay.
Yeah, I just reminded that.
Okay, all right. I just started. Thank you. Okay, so let me open. Let's see what exactly is a join. If you see a picture, you really understand what exactly the join is. As I said, join is a mathematical concept, and join is a concept. Okay, once you understand the concept, that's it. It's very easy to do the implementation of join. Okay. So, as I said, the join is nothing but a mathematical concept. Have you seen a diagram like this when you were in your school, like 11th grade or 12th grade, wherever it is?
Yes.
What is this diagram?
Venn diagram.
Intersection.
Intersection or?
Venn diagram. Venn diagram.
Yes, Venn diagram. And what is it explaining?
Intersection of two.
All right, so this is
intersecting two tables together.
Yes, no, I don't want to talk about the tables. So there are a couple of main join statements, joined options you have in SQL Server. One is called inner join. The second one is outer join. Outer join will be divided again into two: left outer join and right outer join. The moment you understand the left outer join, it will take less than 1 second to understand what a right outer join is. So these are the main joins available in any RDBMS: inner join, left outer join, and right outer join. Okay, so let's take a look at what the inner join does. So if you look at this picture or diagram, what is the specialty of that shaded, green shaded or black shaded area? That area is nothing but the intersection between table 1 and table 2, right? Or the circle 1 and circle 2, whatever it is. That is nothing. So the shaded, dark shaded area is actually the result set of inner join. So what is an inner join? Inner join is nothing but whatever common between table 1 and table 2, that is a result set of an inner join. So mathematically, inner join is nothing. Inner join between two tables means you are trying to find out common records between table 1 and table 2, right? And what is there in the left hand side, this particular white area? This is the records in table 1 which does not have a matching record set in table 2. This white area of table 2 contains records which does not have a matching record in table 1. All the records in table 1 which is having a corresponding one or more records in table 2 resides on this shaded green area. Very simple concept. So when we talk about inner join, or if you want to find out related records from two different tables, you go for inner join. That's a basic thing about inner join. If you are looking for related information, or if you are looking for one or more matches between table 1 and table 2, that information, that record will be available in the shaded area, which is nothing but the result set of inner join. So how does it do the matching? It will take, if I am doing an inner join between table 1 and table 2, it will take the first record from table 1. It will then look at the table 2 and see whether there is any matching records available in table 2. If there is at least one matching record available in table 2, the records from that particular record from table 1 plus those matching records from table 2 will be placed in the shaded area. If then it will go to the second record from table 1, try to find out a match in table 2. If there is a match, again the record from the table 1 and the matching records from the table 2 will be placed in the shaded area. If there is no match, well, that record, the second record from table 1 will be in the white area of the circle. So only thing you need to understand at this point is inner join means matching record set. That match can be one-to-one match or one-to-many match. Did you get my point? Hello?
Yes.
Okay. All right. Some couple of people came late, so let me unmute everybody. Okay. So that is what the inner join is. How about the outer join? So now you need to tell me what is the outer join. Left outer join. In this, well, I said there are two different type of outer joins. One is the left outer join and the second one is the right outer join. So in this picture, we are only talking about the left outer join. So by looking at this picture, can you tell me what is the result, or can you define a outer join, left outer join? Anybody?
Okay.
All the data from table 1 and matching data from a table 2.
Correct. Perfect. In the case of left outer join, it will get all the records from table 1, irrespective of there is a corresponding match in table 2. Well, if you go back to the inner join, what was the definition? We only show the matching records, right? Here what I am saying is, it is going to show all the records from table 1, irrespective of there is a match in table 2, right? That is what the left outer join is. If there is a matching record between table 1 and table 2, that information will also be displayed. So in the left outer join or any kind of outer join, matching is not an issue. Depends upon whether you use the left outer join or right outer join, it will get all the records from either table 1 or table 2. Since we are going for a left outer join, you are telling the system that get everything from the left hand side table, which is table 1. So that's what I said. It will get all the records from table 1, irrespective of there is a match in table 2. If there is a match in table 2, that will also be included. So how about this white region? This region, what kind of record will be there in that white region of table 2?
Not matching.
Yes. Those area contain non-matching records. No, not null. Non-matching record in table 2. But in when you implement the
I have a question.
Yes, go ahead.
Yeah, you're talking about only 2 tables. What if we have more than 2 tables?
I'm getting there.
2, 3, 5 tables.
Yes, I'm getting there.
Okay.
So when you go for a, let's say your requirement says one-to-one match, for example, I want to see all the products which has been sold so far. How do you find out which are the tables? I want to see, let's say your requirement says I want to create a report showing all the products which has been sold. How do you do that? Well, the product information comes from product table. And if the product is sold, there should be at least one entry available in which table?
Sales table.
Sales order detail table. Am I correct?
Yeah, detail table. Yeah, detail table. Yeah.
Yes. So in that case, we are looking for those products which is having at least one matching record in the sales order detail table. So what do you think? What kind of join you will use?
Left outer joins?
Why you want to use the left outer join?
No, sorry, inner join, right inner join.
Inner join, because we are always looking for one or more match, right?
Yeah,
If
right.
one record in product does not have a matching record in the sales order detail, well, that product information shouldn't be there in that report. Am I correct? And that is exactly the condition of an inner join. So inner join, when you implement the join, you always go for inner join if you are looking for one or more match.
Yes, correct.
But if you're looking for non-matching record, in the same example, I want to show a product. I want to create a report which shows all the products which has not been sold. How do you do that?
Then we use the left outer join.
Yes. We go for the left outer join, but there is a trick for that. What is the trick? Well, don't worry about that.
Firstly,
I mean, I don't want to get into that right now. People get confused. So you need to understand that if you are looking for a missing information, okay, you normally go for outer join. We will see how you can implement that. So inner join means you are looking for one or more match. Outer join means you are looking for missing information. The word missing information, sentence missing information can be in different formats. Okay, but in general, if the concept is about missing information, well, or missing records or missing data, then we go for outer join. Normally when you get there, yes, go ahead.
It could be left or right? Outer,
yes.
Left outer or okay.
Yes, that is true. So normally when you get a requirement, there are a couple of steps need to be taken. First step is you read the requirement clearly, then you need to figure out which are the tables need to be used, or which are the tables need to be used to get the information needed in the requirement. Once you decide which are the tables need to be used, well, if there are multiple tables involved, there are more than one tables involved in that process, or the information which you are looking for span across multiple tables, then you need to use one way or the other, you need to use a join, right? Now, if there are more than one table, well, you need to decide what join you need to use. Once you decide what type of join need to be used, then you need to find out which are the columns used to relate records from table 1 to table 2 or something like that. So these are the different steps you need to follow to get the requirement implemented. Okay, so everybody clear with inner join and outer join concept? I'm not talking about the syntax of that, but the concept wise, is it clear? Inner join, one or more match. Outer join, it will get all the records from table either the left table or the right table, irrespective of there is a corresponding entry in the other table. If you go for a left outer join, it will get all the records from table 1, which is the left hand side table, irrespective of there is a corresponding entry in the table 2, which is the right hand side table. If there is a corresponding entry, that will also be displayed. So based on that definition, can you tell me how the left outer join picture will look like? Did I say left? Sorry, right outer join. How the right outer join picture will look like?
Just like the opposite.
What's that?
The opposite. Or
The
mirror.
opposite.
Just look like it like opposite, yeah.
Yes. So the table 1 will be completely shaded. Sorry, table 2 will be completely shaded, and a part of the table 1 is also shaded. Okay, let's take a look at that. So that's one of the reasons why I said once you understand the left outer join, it will take less than 1 second to understand what a right outer join is. Since you say right outer join, you are going to get all the records from table 2, irrespective of there is a corresponding match in table 1. If there is a match, it will also be displayed. Now, if you want to switch this right outer join into a left outer join, what do you have to do? Very simple. Come on.
Switch the tables in the.
Can you repeat that?
Instead of writing the table 1 from, you write table 2.
Yeah. If you want to switch or flip, or if you want to convert a right outer join into a left outer join, very simple. Flip the tables, right? Make the table 2 as your left hand side table and table 1 as your right hand side table, and then you can go for a left outer join. Am I correct? Did you get my point?
Yes.
Okay.
Yes.
So that is one of the reasons why you rarely see right outer join, because everybody has a tendency to go for a left outer join because it's very easy to visualize, the join condition using a left outer join. So you normally see 99% of the time you see left outer join. Even if you need to implement a right outer join, you can immediately make it as a left outer join by flipping the tables. Okay. All right. So is it clear so far? Okay.
Yes.
All right. So there is another type of join called full outer join. This is nothing but the combination of the left outer join and the right outer join. So this will, as the picture indicates, it is going to get the result of the full outer join will show you all the records from table 1 and all the records from table 2. That is another type of join, very rarely get used. Okay. So if you understand the concept of inner join, outer join, we can start talking about how we can implement this in SQL. But if you have any question regarding the concept, this is the right time to ask. Okay. I think we all are good. So let's see how we can implement inner join and outer join. Again, as far as the T-SQL is concerned, one of the complicated, and I wouldn't even say it's a complicated because it's very easy to understand. But some people find it difficult to understand the inner join and the outer join. So please, if you have question, you need to clarify right here, right then. Okay. Okay. Let's go with that. So let's take case by case. My first requirement. My manager give me a requirement, and this is a requirement. I want to create a report showing all the employee ID, the hire date, and the email address. I want to create a report showing employee ID and the each employee's hiring date and email address. All right. So what is the step number 1 I need to go with? We need to find out where I can get the information, right? Where do I get the information? Well, first of all, you go to the employee table, right? Here you go. You look at the employee table. Well, from the employee table, you can get the employee ID, as well as you can get the hire date. But how about the email address? Well, email address is not part of this table. Am I correct? So email address can be retrieved from another table called person.contact. So if you do a simple select on that, here is the email address. So if you execute both, here we go. So you can see that you can get the hiring date and the employee ID from here and the email address from here. So certainly the information which you are looking for is span across 2 different tables, right? So that is our first step. Now we identified what are the tables we need to use, or where our information is coming from. So based on our basic rule, if you want to use more than one table, you need to certainly go for a join. Am I correct? So you decided you need to join between these 2 tables. Now, what kind of join you need to use? That is the next decision you need to make. Well, that depends on, you need to make the assumption that every employee in your company has a contact information, right? So if that's the case, well, we need to go for, if you're looking for one-to-one match, what kind of join we go with? Anybody? Well, we are looking for a one-to-one match here because every employee will have at least one contact information.
Inner join.
We need to go for an inner join because we are not looking for a missing information here. We are looking for a matching information. We go for inner join. All right. So that is the step number 2. So we decided which tables need to be used. Now we decided what join we need to use. Now, how this join will happen. Well, in order to join two tables, well, first we need to decide what kind of join we need to use, and then we need to decide what kind of how we will find matching records. If you go back to the definition of the inner join, the table, all the records from table 1, which is having a corresponding match in table 2, will be displayed, right? Now, how we will find out, how the SQL engine will find out this matching records, or on what basis the SQL engine will consider one record in table 1 as one or more matches in table 2. Well, you need to define join condition. Okay, you need to define on what basis these rows from two tables need to be joined. So if you want to join two tables, well, you need to find columns which is having matching information. Well, normally, I mean, there's a misunderstanding that, you know, you need to look for columns which is having matching column name or matching data type. No, that is not the right way to do. Well, there are situations where table, the employee ID here in this table will also be present in this table as a totally different column name. So you cannot really depend on the data type or the column name to find the matching information. The matching column is purely based on the information that column stores, right? Now, talking about the data, well, it's a very common question. What is the difference between data and information? Anybody? Something unrelated to the join, but can somebody tell me what is the difference between data and information?
So data is organized information.
Okay, data is a number.
Okay. How about information?
Okay, information is like it's implement of an data. Like once you give like context to the number, just like a social security number. Before it was a number. Now you can call like whatever the number is, like social security number. So it's become a information.
Yes. Well, somebody tell me that data, that the information is organized data. I mean, data can be organized, but that doesn't give a meaning for the data, right? If I say 1, 2, 3, 4, what is, I mean, it's just data, right? It's just a number. But if I say that is my social security number, well, we are adding a meaning to that data, then it becomes information, right? Okay. So now if you want to join two tables, well, you need to find matching columns based on, in two tables, based on the information or the data that column has. So by looking at these two tables, can you tell me what columns can be used to join these two tables?
Contact ID.
Contact ID.
Yes, contact ID, because contact ID is available here as well as contact ID available here. But fortunately, well, we are trying to match two columns which is having similar column name, but that is not the case all the time. Okay, so don't depend on the column matching column name. You need to depend on matching information, columns with matching information. All right, so we decided that we go for contact ID to join these two tables. So how the join
I have
will
a question.
Yes.
Daniel?
Yes.
Yeah. I have a question. If there is no matching column available, then
those two tables cannot be joined.
Oh, we cannot include the third table.
Well, yes. I mean, if you have we will talking about that. That is nothing. If you have a third table which is having link to the other two tables, that is nothing but many-to-many relationship, right?
Yes.
Yeah. So you can also have an intermediate table. We will be discussing that later. All right. So, or another way you can say A equal to B, B equal to C, then A equal to C. It's the same concept. Okay.
I have a question.
Yes.
You said that we can't always go based off of the contact, like the header, the actual column name, but we can't go based off the data because the data is not matching within the column. So if the column name is different from one table to another, how will we be able to compare and say that those two tables can unite?
So you are telling me that, please mute the microphone. So you are telling me that you have the same information in two columns in two different tables, but the column name is different. Is that what you're telling me?
Well, you said that the contact, that sometimes the header, the actual name isn't necessarily always the exact same. In this case, we were lucky because it says contact ID, the exact same name on both tables, but you said that that's not always true, correct?
Yes.
Okay, but how would we be able to, let's say if it wasn't the same in this instance, that it is, but let's say if it wasn't, how will we be able to say, oh, okay, those two match, so I can use this table?
Yes. So this is one of the dilemma you will face when you start working on a brand new database. Okay, so normally you will have the ER diagram, or you have the database diagram, and the database diagram, I mean, most of the time the name of the column really makes some sense to you, right? You don't name a column as ABC, or you don't name a column as 1, 2, 3. Normally when you name a column or a table, well, that should have a very close resemblance to the type of information stored in that one. But I have seen tables named as ABC underscore 1, 2, 3. Well, that's a very bad design. You know what I'm saying? A well-designed database the naming convention will have very close resemblance to the information stored in that table or the column. But let's go back to the bad situation where the column name or the table name is not reflecting the actual information stored there. Now, you need to, if you want to find out whether these two tables can be joined, well, you need to do investigation. You need to either look at the database schema diagram. Okay, there may be some articles about that, sorry, some information about or some description about each column in each table in your database. Or you need to look at the table, you need to look at the information or the data in each column, and then you need to manually find out whether these two data can be matched. Did you get my point? But most of the time, if you have a matching information between two tables, 99% of the time, there is a foreign key, primary key relationship exists between those two tables using those two columns.
If they were sorted the same way, it would probably be easier also, because right now they're sorted, you know, they go 1 through 8, and then the other starts at 1,000 something, so it would be difficult without the column headers to tell that those matched.
Well, you need to, well, you can, what you can do is you can sort it based on, as you said, I mean, you can sort it, yes, you can have it sorted too, to identify whether two columns can be joined.
Yeah.
Is my answer clear?
Yeah. Okay, that's where I get what's confused, because it looks like the information inside the
I know you are working with a database where you do a lot of reporting, right?
Yeah.
Yeah, I mean, your first task is get familiarized with the schema of the database and where you can find what information, okay, and then how tables can be mapped. to each other.
Okay.
Hey Daniel.
Yes.
Can I change the relationships?
Yes.
How would I do that then?
You want to? Oh, I'm sorry. I didn't know that it wasn't. Okay, so you want to change the relationship. What do you mean by that?
You know, I worked in Microsoft Access, and I know you can look at the entity relationship diagram and modify the relationship. So.
Okay. And why you want to do that? Because very rarely we go back and change the relationship, because relationship, based on our first class, I mean, we create the use cases. Based on the use cases, we create the ER diagram. Based on the ER diagram, we create the foreign key primary key relationship. And then once the data is there, it is really hard to go back and change the relationship between two tables. You can do that, there's nothing wrong, but if you are going for a very large database and trying to change the relationship or a one particular table, well, you might end up in issue. You can certainly change that, but it's not recommended.
For knowledge sake, where would I go in the SQL Server Management Studio to change that then?
That is the way. I mean, if you want to change the relationship, you can do it either through the SQL statement, if you are familiar with the SQL statement, or you can go to the SQL Server Management Studio and using the point and click method, you can change it. There are two different ways you can do that. Whatever we do through the SQL Server Management Studio can also be done using the SQL statements.
Okay.
Did I answer your question?
So there's no GUI interface where I can change the relationships, or does
yes,
it have
you can use the. You can. I mean, when we talk about the foreign key primary key relationship, we will see how you can change the relationship using point and click or GUI method. Yes.
Okay, we'll come to that later then.
Yes, yes. That's what I said. There are two different ways you can do it. Either using the point and click. When I say point and click, that's nothing but the GUI.
Okay, gotcha.
Or you can use the T-SQL statement to do that. We'll be certainly covering that when we talk about the constraints. Okay, so we decided that. we are going to use these two columns for the matching. So how the matching will work? So you decided that the employee table is going to be your left-hand side table. So it will take the first row from the employee table, right? It will take the first row in the employee table, and then what it will do? It will take the first row and it will try to go to this table, try to find out there is any record in the right hand side table, which is the contact table, where there is a contact ID of 1209, right? So it will scan through that table, the right hand side table, and see whether there is any record available in this table with contact ID 1209. If there is no record available, or there is no corresponding record available based on my inner join condition, this employee will not be displayed in the report. Am I correct? Because there is no match. If there is no match, inner join is not going to entertain that, right? Is it clear, guys?
Right.
If there is one record, if there is a corresponding one record here, well, this employee will be displayed as part of the report. If there is more than one record, well, again that employee will be displayed. So only time the employee or the record from the left hand side will not be displayed if there is no matching. Other than that, one or more matches, that record from the employee table will be displayed along with the matching records in the right hand side table. Here it is the address table. Did you get my point?
Yes.
Okay. All right, so let's go and write the statement. Give me a second. Let me get my normal control back. What did you say?
I didn't get what matching record you talking about. I didn't understand.
Oh, so I'm explaining how internally this matching will happen. So you have, which is the left-hand side table? The left-hand side table is the employee table, right?
Employee table.
And the right-hand side table is the contact table, and that is what you are seeing here. And then it will take the first record from the employee. And what is the contact ID of the first record? 1209, right? So it will try to find there is a corresponding match in the address table using the contact ID 1209. It will scan through this table looking for a record with the contact ID 1209. If it could not find one, well, that particular employee information will not be displayed. If it has one record, matching record available in the address, well, employee will be displayed. If there is more than one matching record also, employee will be displayed. Clear now?
It will not give the next contact ID 1230?
Yes, once this is, well, first it will take the first record. Once it identify whether it should be there in the report or not. So once it will go to the next one, then it will go to the next one, keep on going until it reaches the last row in that table. Yes.
Okay, and if it finds any matching record for 1209 in the second table, so it will not go to the 1660 record?
Yes. It will, what it does is it find, let's say the first record, if it find a corresponding record here, it will display this particular employee in the result set. And then it will also display the corresponding matching record from the address table.
Okay.
And that's what we are going to see now.
Okay.
Okay. So I taken out this explicit column definition. So I'm going with a star here. Okay. And okay, let's go with, so here if you look at the statement, select star from human resource dot employee as E. What is this one? We discussed this before, right? That's nothing but the alternate name, right? Yes, alias. Yes. So, and then I am inner joining with, this is a syntax for the inner join. So then you are saying inner join person.contact. So which is your left hand side table? Human resource dot employee is the left hand side table to the inner join, and person.contact is the right hand side table to the inner join. Am I correct? Okay, now you give an alias for the person contact table too, so it's called as C. On, that is a syntax, and then you need to specifically say on what basis this table need to be joined. So you are seeing, you are telling the system that E.contact ID, which is nothing but this column, right? E means employee table and this column, equals C.contact ID, which is nothing but this column. So you are telling the system that, okay, join these two tables based on the contact ID. All right, so I'm going to execute this. Let me execute with order by clause 2. Here we go. So if you look at this result set or the output of this SQL statement, there are so many columns in this output, right? But if you look at the employee table has only a few columns. But if the result set has a lot of, because when you say star in a join statement, you are telling the system that you want to get all the columns from all the tables in this join condition. When you say star from a select statement, which is only dealing with one table, I mean, you are telling the system only get those columns from that particular table, right? Since we are using the join, well, and star means all the columns from all the tables. So if you look at this, you can see the columns. I'm sorry, let me execute this one more time. All right, so if you look at this, all the columns up to modified date is coming from the left hand side table, which is nothing but the employee, and all the columns from the column ID comes from the address, the person.address, sorry, person.contact table. Okay, so this will give you, so it will take the first employee and then the corresponding contact information is available from this portion onwards. So the output contains hiring date, employee ID, and it also contains the corresponding email address coming from the contact table. Are you with me so far? Hello? Are you with me so far?
Yes. Is the table that we just created called person.contact?
No, it's already available there. The person.contact table is already available there in the Adventure Work table, Adventure Work database.
Hey, Daniel?
Yes.
Are we using HR.employee table as a left table because we need more columns from that table, or we can use
when I say left table, that is to the left hand side of the inner join. Now, why I am using the employee table as the left hand side table, it doesn't matter. In the inner join, we are always looking for one-to-one match. Am I correct? So it doesn't matter which one is the left hand side table and which one is the right hand side table. That is one of the beauty of inner join. Inner join, it doesn't matter which one is the left, which one is the right. Both will give you the same result.
Okay.
Because we are looking for one or more matches. But that is not the case for the outer join. Outer join, the result will be different if you flip the tables from left to right.
Hey, Daniel?
Yes.
When you said that letter E is an alias to the employee table and C is the alias to the person contact table, right?
Mm-hmm.
So when I execute the statement, select star, E employee ID, E hire date.
No, I highlighted, I commented this part, right? It's in green color, so I commented this out.
But why when you execute the whole these 4 lines, you get you get both the tables together?
Yeah, because we have a star here.
Okay. So it will give both the tables.
Yes.
And then the next statement says from human source to employer E. So you are inner joining, but where I'm seeing the tables, like where I can see the person. Where I can see.
Where you can see the table? Yes, you can go to. You have the Adventure Work installed, right?
Yeah.
So if you go to person dot where is it? Okay. Here you go. Person dot contact and human resource dot employee. These are the 2 tables we are talking about.
No, the table which is created when joining them. So
the table is created when we join them.
Yeah, like which has
no. The table was there. The employee table and the person table, the contact table were there even before we joined the table.
Yeah, but when you inner join, so does it create something like which shows
No.
Okay.
It will not create any persistent tables. No. It will execute the SQL statement, read the data, matching information, and show the record set back to you. And that is exactly what you are going to see now. So this output or the result set of the SQL statement is created in the memory, and then from the memory you can see that information. Is it clear? Any other questions?
In terms of performance, will the order in which the tables are listed in the inner join condition matter?
Yes. If you go for a left outer and inner join, it is always a good idea to provide the tables with a less column on the left hand side and columns with more rows at the right hand side. But SQL Engine is smart enough to understand this, so even if you give it in the wrong order, it will flip it and then get executed. So what I'm trying to say is the SQL Engine will not execute the same SQL statement you are trying to execute. It will do some modification if that modification can get the same result set in a quicker way.
In the statement when you say inner join person contact as C on E contact ID equal to C contact ID, can I swap these two statements?
Yes.
Contact ID equal to
Yes,
C
we
contact
can do
ID?
that because A equal to B, nothing but B equal to A, right?
But will that have the same significance even
Yes.
if I keep the first the inner join person contact as
No,
C
it
on?
will give you the same result. The join condition, the highlighted join condition, doesn't matter which one is the left-hand side and which is the right-hand side. It will give you the same result because
No,
you are using an equi operator there, right?
So I'm trying to understand when you say about the inner join, it should have at least one match, right?
Yes, it should have at least one match. If there is no match, that corresponding record from the table 1 or the left-hand side table is not going to be displayed.
So can I write the statement as inner join human resource dot employee as E on E contact ID equal to C contact ID?
Yes, you can.
I can write that also?
Yes. Any other questions? All right. Okay.
Right, you say then select, and then the star means that it's for all the columns, correct?
Can you repeat that again, please?
The star right after select means to pull in all the columns, correct?
Yes. Yes.
Okay, what are the two dashes right behind it?
Well, I am supposed to execute this one first, but I wanted to comment out this block code, so I put 2 dashes. That means whatever comes after that in that line is commented out.
Okay. What if we just went rather than selecting all the columns, you just want to see a report that has employee ID?
Yes, that is what the next step is.
Okay.
All right, so this record, the result set is showing all the columns from all the tables, right? And that's the worst thing you can do as a T-SQL programmer. Because if you are trying to retrieve all these columns, which is not necessary based on a requirement, well, this information should be read from the hard disk, right? So why are you unnecessarily reading all this information from the hard disk? Because based on a requirement, you don't want to see all this information. So always make sure that in the select part of your SQL statement, only select those columns which is needed. Okay, don't even select even a single column which is not needed based on your requirement. So what I can do is I can take out the star and the 2 dashes. So now I am specifically saying E.employee ID, E.hire date, and C.email address. Here we go. So now we join 2 tables and we are getting information from 2 different tables. If you only want to display the employee ID and the hire date, we shouldn't be joining this, right? Because the employee ID and the hire date can easily be get from one single table, which is employee. So that is a pretty straightforward select statement. Okay, all right. Another example.
I have a question.
Yes, go ahead.
Okay, so like employee ID and hire date is coming from like one employee table, right?
Yes.
The other one, email address, is coming from the other table. It's like from like, employee ID 1 is definitely matched with the email address.
No, the employee ID is, we are not matching based on the email address. We are trying to do the matching based on the contact ID on both tables, right? And those record who with a corresponding one or more match, it is only displaying the email address from those matching records in the contact table.
Okay.
If you have multiple, I mean, this example is not the good example for that. Let's say an employee ID has multiple contact information in the contact table. What happened? Well, don't worry about that. In the next example, we are going to see that. Okay. So any other question regarding this? Is it clear how we implement the inner join? Is it clear?
Yes.
Yeah, then Daniel, I have a question.
Yes.
Yes, sir.
If we have some missing data, like hire date is not there,
So it will show the
null
data
value.
or not?
The null value. I mean, the record is there, right? Even if the information in the higher date column might be null, still there is a record, so it will be displayed, and the higher date, for example, if this particular one, this employee ID 3 does not have a higher date, that will show null value there.
It will not affect the result of it.
No. And similarly, the corresponding matching record in the contact table, maybe that employee does not have an email address. Still, it is a match, because a match is actually made based on the contact ID, not based on the email address. So there is a matching record, but when you go and find out the email address of the matching record set, that is null, so it will display null value here.
Okay, thanks.
All right, let me see how everybody is doing. All right.
Daniel?
Yes, go ahead.
I have one question in my mind. Why we are not using anything in inner join, outer join, and we just put condition contact ID is equal to C contact ID and order by high date. So what the same result will get?
Can you repeat that again?
I am talking about if we are not using any inner joined, outer joined word, and just we put the condition contact C contact ID is equal to E contact ID, order by high date, so we will get the same result.
No. Well, another way you can do that without the inner join and outer join, there is an old, it's not a recommended way to do is, you can do the same statement. Don't get confused, okay? You might have seen this before.
Using the where class, yeah.
You can do the same, you can get the same result using something like this, which is not recommended.
Okay.
This is not recommended. What happened is, when you go for an inner join, there are 3 algorithms. Behind the scene, there are 3 algorithms used by the SQL engine to join the tables. It's called loop join. We will be talking about that later. Loop join, hash join, and merge join. This algorithm will make the join much faster than doing something like this. And the join algorithm will efficiently use any indexes available for that column in that table. So that will actually make that algorithm much more faster. So this is a statement. Normally people without much knowledge on T-SQL, those people actually create statements like this. Okay, but this is not recommended.
You mean inner joined and outer joined?
Yes.
You mean inner joined and outer joined using the indexing, and so that will make faster results.
Yes. The algorithm will make the join statement much faster than doing this. Now, if you do this, let's say you are not familiar with the inner join and outer join concept, so you do something like this. Well, again, you can submit this statement, the SQL statement get executed at that time. The SQL engine identify that this is a bad way of coding, so it will upgrade your statement to something like this and then get executed. That's what I say. SQL Server engine is smart enough to understand the modifications. So even if you provide a SQL statement, it will modify it if it can get the same result in a quicker way.
Oh, that's great.
Yes.
Daniel, what's the union command?
Well, we'll be getting there. That's one of the part of the T-SQL statement.
Oh, okay. I thought it would have.
But union has nothing to do with the inner join or outer join.
Oh.
Okay. So I think we can move forward here, right? So let's talk about another table. The next 2 lab exercises is going to be all about inner join and outer join. Okay. let me comment out this part for a minute. So my new requirement, there is a new requirement came from my manager saying that I want to display I want to find sales price of products that are less than the list price recommended for the product. Now we are going to get more familiarized with all these tables, okay? So my requirement is I want to see all the sales price of products that are less than the list price of recommended for that product. Well, we all know that there is a MSRP price and the selling price, right? If you go and purchase anything, I mean, there will be a MSRP price and the discounted price or the selling price. So I only want to see those products which the sale price is less than the listing price. All right, so what is the step number 1? If I want to implement this requirement, what I have to do first? You need to tell me.
Get the tables.
Identify the tables, right? Or where exactly I can get the data. Well, we are certainly looking for the product, so the product information comes from production.product. There's no question about it. Where do I get the sales information? Well, the sales information should naturally come from sales order detail because that contains a line item, right? So let me execute these two tables independently and see what you see there. So the first table is the product table and the second one is the sales order. So now you identify two tables need to be used. Now, how do you identify these are the two tables need to be used? Because in order, based on the requirement, you need to find those products with the selling price less than the list price. Where do you get the selling price? Selling price will easily be available as the unit price, am I correct? As the unit price in the sales order detail table, am I correct?
Yes, correct.
But where do you find the listing price? Listing price is available in the product table. So these are the two information we are looking for. So we find those two tables. Now, based on this, can you tell me how do you join these two tables? Based on the product ID.
Product ID?
Yes. All right, so we have the product ID here and the corresponding product ID. Well, in this case also we are lucky because the column name is the same. All right, so we decided that we can use that. Okay, so we are going for it. Okay, so I mean, I want to display the product ID, the product name, the list price, the unit price. st.unit price is nothing but the unit price coming from or the selling price coming from the sales order detail because the alternate name is SD. And then I am also giving an alternate name for that called selling price because I don't want to display it as unit price, so I want to display it as selling price when it display in the record cell. And then I'm also displaying the sales order ID too. All right. Now, so and then my left hand side table is the product and my right hand side table is the sales order detail. And now I am going to execute this statement. Here we go. So now you need to tell me what you are seeing in the record set or the result set. Is it showing all the products with the selling price less than the list price, or it is simply showing everything? All the products. Is it showing all the products irrespective of the listing price and the selling price, or is it showing all the products with a selling price less than the list price?
It's right now showing everything.
Right now it's showing all the products irrespective of the selling price and the list price, right? Because when you try to join, the only condition you give is this one. So as long as, so let me ask you one more question. If a product has not been sold, do you think you can see that in the record set? If a product, I created a product and which has never been sold, do you think you can see that here?
Yes, I think so.
No selling?
No.
No. Because we are using inner join, right? We are using inner join, and inner join always look for one or more match. So if there is a product without a corresponding match in the sales order detail, what does that mean? That product has not been sold, right?
Okay.
So since we are using the inner join, that product will not be displayed. Okay, so is it clear now why? Is it clear why the product which has not been sold is not displaying as per the inner join rule, right? Okay.
Yes.
Now, if I want to eliminate those products with selling price is equal to, or I only want to display those products with the selling price is less than the list price, how do I do that? You add one more condition here.
Where?
Well, you can use the where. I will talk about that later. In the join statement itself, you can say unit price, sp.unit price should be less than the p.listing price. Now you have two join conditions. The product ID should match at the same time the unit price should be less than the list price. All right, so let's take a look at how this works. So we have two conditions, right? So it will take the first record in the product table, okay? So that is product ID 1. And based on the first join condition, what is the first join condition? This is the first join condition, right? So it will take the product ID, which is product ID 1 for the first record. Then what it will do? It will take this and then it will look at the product ID column here, try to find a corresponding match here. Even so, let's say it finds 4 or 5 matches for the product, but that is not enough to guarantee that this is a matching record. Why? Because we have a second condition too. Once it identifies those records matching for the first condition, let's say 5 records, then it will try to see in that 5 records whether this condition will also be true. Out of that 5 records, maybe 2 records having unit price is less than list price. Then the output, that particular row has 2 matching records in the sales order detail. Am I correct? Are you with me so far?
Yes.
Yes.
So that is how it works. Okay, so if you have multiple join condition, it will go one by one. It will take the first one, try to find a match. If it find a match, it will go and check the second condition. If there is a third condition, then after that it will check the third condition, keep on going like that. But if the product ID 1 does not have a corresponding entry in the sales order detail based on the product ID column, there itself we understand that there is no corresponding match, that product is not going to be displayed. Let's say the product ID 1 has 5 matches in the sales order detail table based on the first condition. Then it will try to check the second condition. In none of the 5 records match this condition. That means product ID does not have any match on the sales order detail table based on the condition we provide. So that product information will not be displayed in the record set. Did you get my point?
Yes.
Okay.
Daniel, can we use the having condition here instead of and?
Having? You said having or where?
Having condition instead. Having.
No, having cannot be used. Having always comes with the group by. That's a totally different thing. No, having cannot be used here.
Okay. Okay.
Any other question? Can we use or?
Yes, you can use. I mean, you can use or. So now you need to tell me what difference it makes.
Or.
Okay, give me a second. Let me execute this and show the result first. All right, so this will show you all the products with list selling price is less than the list price. But now, why the product ID 707 displayed multiple times? I don't know how many times it get displayed, but the product 707 displayed so many different times. Can you tell me why?
Multiple matching records?
Yes. What does that mean? Multiple matching record in this case, what exactly the meaning of that?
Left side table has a many matching record in the right side table.
Yes, yeah, I understand. But what is the literal meaning of that? The product 707 has been sold for less price than the listing price multiple times. Am I correct?
Yeah, right.
Yes.
Yes.
So this clearly indicates that if you going for a inner join and one record in the left hand side table has multiple corresponding or matching record in the right hand side table, there will be multiple records for each entry or each matching entry in the right hand side table. All right? Did you get my point? In the previous example, employee contact, it's always one-to-one match based on my business logic. Here we can have more than one match. If you have more than one match, for one record, there is 5 matches in the sales order detail. That one product record will create how many records in the output? Please mute your microphone if you're not speaking. My question is, one product, let's say the product ID 1 has 5 corresponding records, matching records in the sales order detail table. Based on my select join condition, that single product record from the product table creates how many records in the output? Come on. Hello?
You said 5 of them?
Yes.
5 records in the...
Yes, of course, 5 of them.
So
there will be
5.
There will be 5 records.
There will be 5 records.
Okay. So I believe you understand what I'm talking about. Okay. So now somebody asked me what happened if I change this AND condition to OR condition. So now you need to tell me what will happen. Anybody?
No, I got that. It will show both results. It will match one of them. So it will actually not going to satisfy our requirement.
It will not satisfy the requirement. Why?
It will show us the other records too who have more list price than the unit price.
Yes. Yes. It will check in the case of OR condition. If this statement is true, or this condition is true, or this condition is true, it will identify that record in the sales order detail as a matching record, right? But if you are using the AND condition, both condition has to be true to get a true value. If you go for a OR, well, I mean, you can use the OR, there's nothing wrong with that as long as your requirement supports that. Did you get my point? Okay. I think it's time to take a break. So it's 10:17. Come back at 10:23 and 10:23, and then we will continue. Thank you. Hey Shantini, can you hear me clearly? Everything is okay at your end?
Are you talking to me?
No. I'm talking to Shantini. Shantini, can you hear me?
I was on mute. I can hear you.
Yeah, everything is okay at your end?
Yeah.
Okay, good. Yes. Yes.
Yes. Do I need only SQL server installed on my computer standalone basis, or then we go for administration? Do I need to connect it to the network, with the network?
The network, no. You might want to get a second instance of SQL Server. I will inform when you want to do that. And that's more than enough to cover the DBA.
Okay.
I mean, if you're able to create a home network, I mean, that's fine too. I mean, if you are expert in that, go ahead and do that.
That's fine too. Expert in that, go ahead and do that. Because I have
if you have if you know how to create the network, you can go ahead, and then what you can do is you can have the second instance on another machine, this network.
You can have the second instance.
Hey Daniel, I cannot hear you at all.
Oh, we are on a break. Can you hear me? Hello?
Yeah, you were explaining something, and I was listening, and all of a sudden, the voice went down. That's what I was wondering. Never mind. I can hear you right now. It's okay.
Okay.
Thanks.
All right. All right, so I think we can get started here. Any specific questions before we get started? Okay, so when I was explaining this particular statement, and somebody asked me, can we go and implement the same logic using a where condition? Well, when I say where condition, I'm not talking about the join. The second part, the second condition, this one, the unit price less the list price. Well, you can do. So let's again execute this without the second condition. So as you know, this is going to display all the product irrespective of whether the unit price is less than the selling price is less than the listing price. So this is the record you have, right? So this display everything, and if you want to filter out those records, or you only want to see those records from this record set with the list price, the selling price is less than the list price, how do you do that? You will say where you can use the same condition here. This will give you the same result as doing at the join condition. So the same thing can be done in two different ways. You can implement it as part of the join condition, or you can actually do it as part of the where condition. Which one is better choice? Anybody?
Join condition.
Why?
Because of the order of execution, where comes much after inner join.
Yes. So the basic rule you need to follow is, if you can filter record at least one level above, that is the best. If you look at the SQL execution order, the where condition actually happens below the join condition, right? So if you go for the where condition, you are eliminating the unwanted records one step below, comparing to eliminating it as part of the inner join. So even if you can do something like this, it is recommended to do that as part of the join condition. Now again, even if you give a statement like this, SQL will upgrade this where condition into a join condition for a quicker result. Okay. All right. So I think we made some good progress with the inner join, and hopefully there is no questions from anybody. Do you have any questions? I keep on asking because this is very important.
Yeah, Daniel, I have questions.
Yes.
I'm still not clear with this when you did the select P product ID P dot name P list price as selling price, as selling price. Why did you name this as selling price?
Well, I mean,
and
yeah, this is a dynamic name. I mean, I commented out, and then if I execute this, well, this is going to be like unit price. But if you look at, I mean, unit price, I mean, that's what I always say. When you name the table or the column, or when you display as a record set, always make sure that you give some meaningful name. But if you look at the unit price as a column name, that doesn't make any sense, right? So I'm going to give a more user-friendly name. So I rename that column just for the display purpose as selling price. So if I execute this, you can see it as selling price, which make more sense.
So selling price is the name given to the unit price. Is that
yes, this is just a dynamic name I create on the fly. We are not going to change the column name at the table. When the column is displayed, instead of unit price, I want to display it as selling price. That's it.
So in this query, what you're doing is that you have a table called production.product, right?
Yes.
And you you're basically inner joining the sales order detail with the matching with matching of product ID from the product table and the sales. What is the other table?
The unit price, the listing price on the other table.
Okay. And then what is this sales order detail ST? So ST, isn't that the earliest name which you have given?
Yeah, that's the earliest name for the sales order detail. When I say SD.unit price, it's nothing but sales order detail.unit price.
Okay. So I'm just trying to understand what tables you are taking and what columns you are fetching from which table and okay.
Okay. All right. So you can look into that, and if you have any question, let me know. Okay. As long as you understand the concept, then that's what I'm trying to do that in today's class. And then regarding the statement and the syntax, well, you will get more familiarized with it when you do the lab exercises. Okay. All right. So another requirement. Another requirement says, I want to see, this requirement remains the same. I want to do it specifically for two products, product ID 718 and product ID 776. I want to see those transactions for product ID 718 and 776 where the products are sold less than the listing price. Well, based on this particular SQL statement, I will get all the records, right? All the products with a selling price less than the list price. But if you want to be very specific about a particular product, well, you need to add one more condition saying and in bracket product ID equals 718 or product ID equals 776. That's another condition. So if you execute this, this will only show product 718 or 776 which has been sold for lesser price than the list price. I don't think there is any explanation needed. The only reason why I added this SQL here because just want to give you an idea how you can mix match the AND condition and the OR condition. Very simple. Okay. So let me see what is next. Now we are going to see. So now you need to.
As the product ID is the same, like you are using uppercase.
Oh no, it's the same thing because by default the SQL is not case sensitive.
Okay, yeah.
All right. So now you need to tell me what kind of relationship exists between the product table and the sales order detail table. One-to-one, one-to-many, or many-to-many?
One-to-many.
One-to-many relationship. All right. So if you have tables with a one-to-many relationship, it's pretty simple. You can use a simple inner join. But how about many-to-many relationship? How you retrieve data from many-to-many relationship? For example, a classic example for a many-to-many relationship is product and vendor. So let's say you are running a manufacturing unit and you have multiple products required to do the manufacturing. Or let's say you are doing a manufacturing unit and then you are trying to sell your products through the vendor. Okay, that's a good example. So you have multiple products and you are trying to sell it through different vendors. So what is the relationship between a product and a vendor? Anybody?
One-to-many.
One-to-many.
Many-to-many.
Many-to-many.
Okay. So why did you say it is many-to-many?
Because 4 or 5 products can be sold by a single vendor, and a single product can.
Yes. One product can be sold by multiple vendors. Okay. And one vendor can sell multiple products. So from either side, it is going to be many-to-many relationship. How we implement many-to-many relationship? We are using 3 tables, right? We explained that in the first class. But at the same time, even if you are using 3 tables, there is no direct relationship between the left-hand side table and the right-hand side. When I say left and right, don't confuse with the left and right table on the inner join and outer join. I'm going back to the tables which I displayed as part of the Excel spreadsheet. So there is no direct relationship exists between the left-hand side table and the right-hand side table. Am I correct? The relationship actually goes through the coupling table or the intermediate table. Or the example which we saw is the the patient and the doctor, right? And there is no direct relationship between the patient table and the doctor table. It is actually go through that intermediate table. So if you want to retrieve data from a many-to-many relationship table, well, you need to use 3 different tables. So if you want to use 3 different tables, well, there will be 2 inner joins, right? If you have 2 tables, 1 inner join. If you have 3 tables, there will be 2 inner joins. Okay, so my requirement says I want to display all the products and their corresponding vendor. How do we do this? My requirement says I want to see all the products and the corresponding vendors. Well, first of all, we need to identify which are the tables need to be used. Well, product information coming from the product table. Vendor information coming from the vendor table. Well, those are the left-hand side table and the right-hand side table in the many-to-many relationship. And then there is an intermediate table, and that is called as product.vendor. So let's take a look at what is there in these tables. These are the 3 different tables. Give me a second, let me organize it in a better way so that you can see it. Okay, so this is the product table. This is the vendor table, and right in the middle you have the intermediate table, or we call it as coupling table. So if you look at the product table, well, the product table has product ID, the vendor table has vendor ID, but there is no direct relationship between the product table and the vendor table. So if I want to find out which are the products sold by a particular vendor, or which are the products sold by a particular vendor, or which are the products, or which vendor is selling one particular product, you need to go through this intermediate table. Certainly we are going, so what kind of relationship what is your requirement? You want to see all the products sold by all the vendors. So we are looking for a one-to-one match, right? If a product has not been sold, well, we need not have to solve the vendor. So we always need to look for a one-to-one relationship. How do we establish? So we identify the tables. Now we need to identify how the join will happen. Well, what you can do is you need to take the product ID. So can you tell me how we will do the join? We have a match. First we need to find how to match the product table with the product vendor table. So we have a product ID here and we have a product ID here. That is going to be a matching column to relate the product table with the product vendor table. Then how do you relate the vendor table with the product vendor table? Well, we have a vendor ID here that will be matched with the vendor ID in the vendor table. So this is very similar to A equals to B, B equal to C, then A equal to C. The mathematical formula, right? So how this statement works? So if I implement this statement with the 2 inner join, it will take the first record from the product table, because that is the left hand side table, and then take the corresponding product ID, which is 1. Then it will scan through this particular table, try to identify all the rows with product ID 1. And there may be multiple rows with the product ID 1. Then let's say 3 tables are there with 3 rows are there in the product vendor table with the product ID 1. Then it will take the corresponding 3 vendor IDs for those 3 records. Okay. And then it will take that particular vendor ID, try to scan through this table to get more information about that particular vendor. Did you get my point? So it is a chain. I would say it's more, this process is going to be more like a chain. It will take first record from the product, try to find a corresponding match in the product vendor table. If it find a corresponding match, one or more corresponding match, then it will use the corresponding vendor ID in that match record, and then using the corresponding vendor ID, try to find corresponding records in the vendor table. Okay, and then get the record. Let's say there is a vendor ID in the vendor product vendor table, does not have a corresponding record in the vendor table. That means it is missing information, right? Even if the missing information happens between these 2 records, these 2 tables, still it is considered as a missing information, and that particular product ID will not be, that particular product information will not be displayed. So even if you have multiple inner joins, even if, so if there is a missing information in any of the step or any of the inner join process, it is considered as a missing link, and the record will be eliminated, or it will not be as part of the record set. Complicated? Do you understand it? What do you feel?
Just need to apply it.
Okay, let's go and apply it as you said. Okay, so what I'm doing is, well, my leftmost table is the product table. Okay, and I am trying to join the product table with the purchasing.product vendor table using the product ID columns in both tables. And then I am trying to inner joining the purchase product the product vendor table with the vendor table using the vendor IDs. Okay, and then I am getting the product name from the product table, and the product subcategory also coming from the product table, and then the vendor name is actually coming from the vendor table. So if I execute this, here we go. This display all the products, its corresponding product subcategory, and all the vendors selling that particular product. So if a product has never been sold or never been assigned to a particular vendor, that product is not going to be displayed here, right? And you can add information from the middle table too. So what information is there in the middle table? Okay, let's take a look. There will be multiple, okay, here we go. Unit measure code. Okay, well, I want to include the unit measure code. Certainly I can do that. So pv.unit, where is it? pv.unit measure. Okay, here we go. So this information is coming from the middle table too. What do you guys think? Now we are going to, we are inner joining, or we are trying to link 3 tables using 2 inner joins. Confused? Questions? Are you ready to do the homework assignments on joins?
What are the tables of
Yes.
PV is the product vendor table.
Can you repeat that again? I did not hear you clearly.
PV is the product vendor table, right?
Yes.
Okay.
PV is a product vendor table. Yes. That's an intermediate table.
Okay. And the last table is the vendor table.
The last table is the vendor table. Yes.
Okay. So you are going from product name to the product. What is the second one? Okay.
It's very simple.
Product.
You get the product, one product at a time from the product table, and using the product vendor. In the product vendor, you are trying to find out which are the vendors for that. And using that vendor ID, you go to the vendor table and getting corresponding information about that vendor.
Okay. It's a chain of events.
Yes. Absolutely. Well, if you look at this, well, it is only displaying product subcategory, right? Code. I mean, it's only displaying this product subcategory code. Well, when we talk about outer join, we will explain how you can get the product subcategory name. At this point, it is tougher, so I'm skipping it. But later we will be discussing. But I want to add one more criteria. I only want to display the vendor information for all the products coming under a particular subcategory. All right. For example, I want to display only vendors coming available for all the products with the subcategory ID 15. Well, only thing you need to do is add that join condition here. So you are locally looking for product subcategory ID 15. So if I execute this, here we go.
So Daniel, we have to add the condition right by way we put in the table.
What did he say? The condition?
Like the condition, we put the condition product ID equal to category ID equal to 15. So, and it's from the purchase, it's from product and production and product table, yeah?
Yes. Because this is actually the... Go ahead.
Where we should put the condition, it matters, or we can put the condition after the second in join?
You cannot, yes, you can also do that. No, you see, which statement actually link the product and the purchasing.product vendor? The first inner join, right? So that is where you need to put that. Here, you are trying to link the product vendor table with the vendor, and this is not the right place to put it there. So whichever inner join responsible for joining that table with another table, that is where you need to put all this condition. Or you can also put as a where condition if you want to do that. But it is not recommended. So, is it clear? Hello?
Yes, if we put where condition, then we can put it at the end, right? Yes.
Yes, it is not recommended. But you can also say. Well, I'm going to comment out this. It will give you the same result. I hope you understand why it's giving the same result, and at the same time why it is not recommended to do that using the where condition, right?
Yeah.
Yeah, it's based on the performance. All right, so let me see the lab exercise in a minute. Give me a second. Okay, file labs. So lab number 2 is about I don't know whether you can do the lab number 2 because most of the steps here it's about the null statement. So you may want to skip the lab number 2. If you can do that. That's not a problem. But after lab number 1, I want you to go straight into lab number 3, which I am going to upload after today's class. So let's take a look at what is there in the lab number 3. So the lab number 3, oh, wait a minute. I'm sorry, I think I messed it up. If you go back to the lab number 2, the lab number 2 is about the joins. Give me a second. Yes, the lab number 2 is about the join, the inner join. So please start doing the lab number 2 after today's class, and then I believe I have more labs on. Give me a second. Lab number 4. I have more labs coming on lab number 4 and 5. That is also about the combination of inner join and outer join. So at this point, if you finish with once you finish with the lab number 1, go ahead with the lab number 2, which is inner join. And I always recommend you to do the lab as soon as I finish a topic so that you will be still in touch. If you try to do that after 1 week, probably you can do that by reviewing the video and then do it. Okay. All right. So I think that's all for tonight. Any questions? So tomorrow we are going to start with outer joins. And after the outer join, we will be seeing the combination of outer join and inner join. Then we will go to the aggregate function, the aggregation of data using group by and having.
What is to be read from the ebook as of now?
Mm-hmm. What did he say?
I mean,